So today I'm gonna continue to study Rust. I didn't study that much this past couple of days because I was trying to finish the book that I had on Python network, and there was still a bunch of pages left, so I was trying to read it as fast as possible so I can go start reading this book here that Olala, someone that got into the stream recommended. I don't know if it's visible, but it's modern operating systems. And the reason why I wanted to read this book is because to finish the other books, because I think the this other one is gonna help me understand Rust as well a little bit better. Not Rust, but understand. I'm trying to bridge the gap between programming languages and then compilers and assembly and the operational system because I want to understand how everything works eventually. So I think this book is way better to read along as I learn Rust than the other book because it's more complementary. The other one was about Python and networks, so yeah. But I think today what I'm gonna do is read this book here on Rust, and I got this idea from. Oh, I also think I'm gonna. Oh, this guy has. Didn't realize that was the same guy, but I have some videos here from him. Based on assembly, and I think I'm gonna watch these videos as well.
When we write programs in Rust, we tend to
And another thing that I think I'm gonna do is post on Twitter, even though I don't feel like it. I wrote this thing here because the reason why I don't like it is because I think social media is a waste of time, but it's part of the day. It's part of it's part of life, uh, the world we live in. So I don't think I can. I have to take advantage of it. So I think what I'm gonna do is uh, try to post things I learn on stream, and then post here as often as I can. Yeah. And before I start reading, I got the idea from this guy here. Yeah, this guy. It, that's pretty much what I'm gonna do is follow this book and then write it down here. And then yeah, later maybe watch this. And there is a podcast I wanna watch, which is with Lex Friedman and John Carmack, I think is his name, which is a 5 hour podcast and seems really interesting because they talk about AGI. And John Carmack, I think, is the guy that created Quake and he's probably one of the best programmers of all time. So I think it's good to listen to the podcast and um, have his take on a bunch of different things. I already listened to a little bit, and they were talking about programming languages. And he also talked. He said that is well, actually, I don't want because he said a lot of things. I don't want to misrepresent what he said, but he talked about that he knows C++ and all of the stuff, and yeah, just the normal stuff that it's definitely good as a developer to know the lower level languages because that gives you a higher resolution over how the other languages work. But that doesn't necessarily mean that coding on the other languages is bad, which I think I agree with. But yeah, I think it's something that I'm gonna have to do at some point after learning Rust is learn assembly as well, and then try to get as much accuracy as I can over the way that everything works. The operational system, assembly, and lower level languages, and the integration of everything. That's the goal, at least. So after I get tired of reading the book, I might watch some videos, or I might stop streaming and then go listen to the podcast. And I think I'm gonna train Vim for 15 minutes before starting the book because Yeah. I want to make sure I have the fundamentals of Vim down before I move on to other things more advanced. So I think I'm gonna stay for a while with these simple commands here. But I think half an hour is probably too much. I'm not sure. I think I remember all of them. But I still have absolutely zero experience with uh, actually using them in practice, obviously, because I haven't coded since I started learning this. So I imagine it's gonna be, I wanna have at least some experience actually coding stuff and trying to use the key bindings before I move on to other more advanced things. Hmm, fuck. I'm getting some of them wrong, but it's not because I don't know them, obviously. It's just because of the text. I'm trying to do it too fast. I still feel like even though I know all of them, it's not gonna be intuitive to move around. I still have to think about it. That's the problem. But I'm not sure if that's gonna go away or not. I think probably maybe when I start using for a long time, it's gonna take a while, I think. Because it's kind of annoying if you're thinking about something else, you have to consciously remember the key binding to do something. But I have no idea how long it usually takes for people to be able to do that. I definitely know that it's possible because I've seen people using Vim and it's pretty natural. They don't even, it doesn't seem like they're thinking about it. I think I haven't had enough of this. I'm gonna start this timer and then read the book. Okay, the first step, installation. I don't think I'll read everything out loud, but yeah, the important parts probably. Already gone through the installation, so I think I'm gonna go fast through this one. Let's try this. Now that you've installed Rust, let's write your first program. It's traditional learning a new language to write a hello world, screen, hello world. This book assumes basic familiarity with the command line. Rust makes no specific demands about your editing or tooling or where your code lives. So if you prefer to use an integrated development environment instead of a command line, feel free to use your favorite IDE. Many IDEs now have some degree of Rust support. Check the IDE's documentation for details. Recently, the Rust team has been focusing on enabling great IDE support, and progress has been made rapidly on that front. Start by creating a project directory, running. Okay. And I think I'm gonna actually write everything down. So I got some practice writing things down. I watched a couple of videos during the time that I didn't stream on Rust about a few things, but I'm still having difficulty understanding. I'm gonna have to research, I think, after I read this book. I'm gonna have to research about the implementation, the implement keyword and struct and how they go together because I couldn't find videos that I found a couple of videos that explained, but they didn't explain really well. And it didn't talk about the concepts that we'll have to. It's wrong. Well, I guess when you are highlight, I have to do something. Oh yeah, of course I can't do that. I was pressing shift, but it doesn't work because I'm not on the main mode. And enter just goes there. So now I can use I and then do this. So I have the tendency. Yeah, that's one of the things that I'm not sure about because in order to go back and forth, you have to press I, and it's kind of weird. I'm not very used to that because then if you press I, you have to press this again to move with the Vim bindings again, and it does get a little bit confusing. Maybe I should change the command to get back into the or to get into insert mode. And because now I can press shift, I have to use the arrows to delete. There's probably a command for it that I don't know. There's definitely a command that I don't know. But whatever. I'll learn it later. It is kind of difficult though, because you have to go in and out of the insert mode and the normal mode. Yeah, hey Ola, what's up, man? Yeah, I'm learning Rust and Vim simultaneously. Trying to. Uh, Yeah, so I think I'm gonna copy this stuff so I learn more by writing. Run your Rust program. Next, make a new source file and call it main.rs. Rust files always end with their .rs extension. If you're using more than one word in your file name, the convention is to use an underscore to separate them. So I think it's the same as Python. For example, use hello world rather than hello world. Now open the main.rs file you just created and enter the code in listing 101. So in the beginning, when I don't know a lot of key bindings, it's gonna be really awkward, I think, to write everything because I have to constantly go back and forth. But I hope that once I learn more advanced commands, I can do everything on the normal mode, let's say. Because now I have to do this and then back again. It's kind of, but I'm not sure if this is the way that people do it. Yeah, I don't know, man. It's just an intuition. I just the first time that I saw the car, I did a course from zero to mastery. Pretty much I paid 40 bucks, I think, and they had a bunch of different courses. So I actually did 30 courses in 1 month, I think, from them. And one of those courses was Rust, and I thought that the course on Rust was the best one out of all of them. And for some reason, I just did. There's something about the language that I really liked. I don't know how to explain it. And then later on, from the videos I've seen, it seems like it's a more functional programming language, and there's no, it's not really object oriented. It's more composition oriented. And I always felt that I lean more towards composition than objects because I usually don't do classes a lot, but obviously I don't have a lot of experience building a lot of stuff. So, but I think I gravitate more towards that. And I also want to learn. I want to have practice with a lower level language. And I think Rust and C++ are very similar in the level of the language. Let's say. So I'm probably going to learn a lot of important concepts that I don't use just by I coding on the other languages that I've have had experience so far. And yeah, I think is the right and something there's is more of an intuition. I think is gonna be good. And the other thing that made me want to do Rust is that I was trying to do the stuff on Python of analyzing data, and I couldn't open the files that I have because they are too big. And I was looking for libraries to be able to open them. And one of these libraries is called Polars, and Polars is written in Rust. So after reading that article, I decided like, why not just learn the language, and then as my first project, I tried to incorporate the language to make data analysis myself, to get the data from the web tree and analyze it with Rust, and then only do the machine learning part on Python. You make straight traits instead if classes interface is not a big deal. Yeah, stream instead of reading them. What do you mean? Save the file and go back to your terminal window in the project's hello world directory. Linux, Windows, blah blah blah. Regardless of your operating system, the string hello world should print to the terminal. If you don't see this output, refer back to the troubleshooting. Oh, I have to run. I didn't run it. So I think it's like this. Yeah, Windows. Oh, so I have to. Let me try like this. That doesn't work. Also didn't work. Oh, I need to go to the right folder first. Let's see if this one. Python is being used for enormous datasets. There is no need to fit everything into memory. You can stream your file, your file, i.e., deal with it in chunks of certain size. Yeah, but I still think because it's not just that. I think it's a multitude of reasons that go into learning Rust. It's both because I like the language, because I think it's gonna be useful, and I think it's gonna make me a better programmer overall, because I'm gonna have to deal with things that I don't in Python. And it's not like I lose anything, because if I want, I can just code in Python then after I do everything on Rust. It's not a big deal, I think. I think it's worth the time invested. And I'm also thinking about learning some assembly after I learn Rust. Yeah, thank you. Because I want to understand as much as possible everything that I can about the whole process without, yeah. Because I don't think those things are really. I'm gonna have to learn them eventually. I'm just not sure what's the best way. I think I'm gonna try to incorporate as much as I can with the overall goal that I have now, and then yeah, yeah, not sure. Yeah, I it's not from. It's more from a skill perspective, I think. It's just gonna increase my understanding and make me better, I think. It's the same reason why I want to learn operating systems. And I started reading this book that you recommended today. Not sure if you can see it, but it's Modern Operating Systems by Andrew S. Tannenbaum. Tannenbaum? I don't know how to say it. But I just want to understand 100%. Not 100%, I want to have a very clear understanding of the whole, how everything works. But I'll go back and forth probably, and probably change my mind several times. It doesn't matter as long as I'm improving every day. I think that's all that matters. I don't think I can. I think I can skim through this because I don't. It's really beginner stuff. Yeah, but most people in most areas don't are not very good at what they do. If you look at the best people ever, they all know assembly. All of the people that I've seen that are considered the best programmers, they all know assembly. So, I mean, I don't want to be. I want to be the best, right? At everything I do. So I think it's inevitable. Linux, macOS, and PowerShell on Windows, you can see the executable by entering the ls command in your shell. You see two files with PowerShell on Windows. You see the same three files that you would see using CMD. With CMD on Windows, you would enter the following. This shows the source code file with .rs extension, the executable file main.exit on Windows, but main on all other platforms. And when using Windows, a file containing debugging information with the .pdb extension. From here, you run the main on main.x file like this. main.is is your hello world program. This line prints hello world to your terminal. It didn't print anything. Oh, it's because I put the semicolon, maybe. I think in Rust, when you don't put the semicolons, is the same as typing return. But I also didn't output anything here. Uh, so maybe I'm doing something wrong. What if I just do Rust instead of Rust? Yeah. It looks like it is running, but maybe I do need to read this stuff. And they also put the semicolon here. That's why I think I did it. Do you really think that all the staff engineers at, let's say, Oracle know SM? No community, Node community. Yeah, man. I don't know. I don't really don't really care. Uh, the only thing that I care is about understanding everything that I can in relationship to what I'm moving towards, and that's all that matters. So the question for me is not whether or not I have to learn these things, is more of time and the priority based on the circumstances I am right now. But given enough amount of time, I'm gonna learn it eventually anyway. It's just a matter of how much is gonna help me based on whatever is happening right now, which is impossible to tell because there's so many variables involved. And that's why it's hard and I go back and forth between things that I'm doing. Oh, main.x instead of main. But I think I did this one. Oh no, I have to run the executable because this one is the compilation. I think I understand now. Maybe if I put the dots, yeah. Okay, now it works. That's a view. So compiling and running are separate steps. You've just run a newly created program, so let's examine each step in the process. For running a Rust program, you must compile it using a Rust compiler by entering the rustc command and passing it the name of your source file, like this. Have a C or C++ background, you'll notice that this is similar to GCC or CLang. After compiling successful, Rust outputs a binary executable. I wonder if there is a command to do both at the same time, or if it's a best practice to compile first and then execute. Because it seems like it is more work to run one and then the other. But I guess you only have to, maybe not, maybe you compile every time actually, after making changes. With CMD on Windows, you enter the following. This shows the source code file with the .rs extension, the executable, blah, blah, blah. Yeah, okay, next one. Cargo is Rust build system and package manager. Most workstations use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. Simple Rust program written so far in the dependencies. Okay, because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo true. Cargo comes installed with Rust if you use the official installers discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by entering the following. I think I'm pretty positive, but I'm gonna do it anyway. Because, yeah. So, version number, blah, blah, blah. Creating a project for Cargo. Let's create a new project. I already did this. The first command creates a new directory. It feels like this should come before hello world, I think. Has now generated. Has also initialized a new Git repository along with the .gitignore file. Git files won't be generated if you run cargo new within an existing Git repository. We're using cargo new vss equals Git. Git is a common version control system. You can change cargo new to use a different version control by changing the flag. Okay. Open cargo.tom in your editor of choice. It should look similar to the code in listing. Okay. This file is in the Tom's obvious minimal language format, which is cargo's configuration format. The first line package is a section headline. Okay. I think this is, yeah, too basic. I already watched some videos about this, I think. We started a project that doesn't use cargo as we did with the Hello World project. You can convert it to a project that does use cargo. The project, okay, building and running a cargo project. Now let's look at what's different when when we build and run the Hello World program with cargo. From your Hello World directory, build your project by entering the following command. So cargo build. This command creates an executable file in target debug hello cargo.x on Windows rather than your current directory. You can run the executable with this command. Hmm. It's pretty much the same thing, it's just a different folder. Oh, but it's the same. It's a different file, I think. I think I understand, so I'm not gonna do that. But it's pretty much the same thing. Create a files here for the executable. So just type the path and then it's gonna execute. If all goes well, should print terminal running cargo build for the first time also causes. It's pretty similar to npm, I think. npm builds. To create a new file at the top level cargo.log. This file keeps track of the exact versions of the dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. Won't ever need to change this file manually, cargo manages its content for you. We just built a project with cargo build and ran it with this, but we can also use cargo run to compile the code and then run the resulting executable all in one command. Okay. Now, this is what I was thinking about because it makes more sense. And I think I've seen this in some videos as well. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary. Some most developers use cargo run. Notice that this time we didn't see output indicating that cargo was compiling hello cargo. Cargo figured out that the files hadn't changed, so it didn't rebuild, we just run the banner. Okay. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. I think what I'm gonna do is open the file that I have for Rust and I'm gonna write this down. Write these commands down. Just in case I forget them. Which I probably won't, but It checks your code to make sure it compiles but doesn't produce an executable. Why would you not want an executable? Often cargo checks much faster than cargo build because it skips the step of producing an executable. If you're continually checking your work while writing the code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many rustations run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Let's recap what we've learned so far about cargo. We can create a project using cargo new. We can build a project with cargo build and cargo run to run, cargo check to check if it compiles. Instead of saving the result, cargo stores it in the target debug directory. An additional advantage of using cargo is that the commands are the same no matter which operating system you're working on. So at this point, we'll no longer provide specific instructions for Linux and macOS versus Windows. Building for release. When your project is finally ready for release, you can use cargo build release to compile it with optimizations. So cargo builds. Maybe I should go back and write this down. Builds projects. This command will create an executable and target release instead of target debug. The optimi- okay. The optimizations make your Rust code run faster, but turning them on lengths the time it takes for a program to compile. This is why another thing that I've seen people talk about that is one of the downsides of Rust is that it takes a lot to compile. This is one of the complaints that people have, but yeah. Overall, from what I've seen, I think it's pretty good on the other metrics as far as people talk about. And on the Stack Overflow survey, also people seem to like the language. This is why there are two different profiles, one for development and when you want to rebuild quickly and often, and another for building the final program you give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build release and benchmark with the executable in target release. Cargo as convention. With simple projects, Cargo doesn't provide a lot of value over just using Rust C, but will provide its worth as your program becomes more intricate. With complex projects composed of multiple crates, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using Git. Change change to that project's directory and build. Okay, summary, you're already off to a great start. Install the latest stable version, update to a newer Rust version, open locally, install documentation, write and run, using Rust directly, create and run a new project using the conventions of Cargo. This is a great time to build a more substantial program to get used to reading and writing Rust code. So In chapter 2, we will build a guessing game. Okay. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. Learn about lat, match, methods, associated functions, using external queries, and more. The following chapters we will explore these ideas in more detail. This chapter we will practice the fundamentals. We will implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Maybe I should write this stuff here. I think for this I already have it written here, but I think I'm gonna write some things, at least I think 3 things for posting on Twitter later. So I think one of those things could be that. To set up a new project, go to the projects directory that you created in chapter 1 and make a new project using cargo like so. First command cargo new text. Okay, already saw this. As you saw in chapter 1, blah blah blah. This is hello world program and run it the same cargo one. The run command comes in handy when you need to rapidly iterate on a project, as we'll do in this game. The other thing that I've seen people complain, not complain, but say that it's hard on Rust is strings as well. So I think it's both strings and then the borrowing thing, which is hard. And then the other thing that I just talked about that I forgot. Oh, the compiling thing. Processing a guess. The first part of the guessing game program will ask for user input, process that input, and check that the input is in the expected form. To start, we will allow the player to input a guess, enter the code in this thing. I think this is gonna be a little bit hard. Yeah, I can't really. Oh, I can't go with this one. Then I have to do this again. It is kind of hard to go back and forth between the modes. Not gonna lie. My instinct. I'm not sure if people do it like this, but my instinct is to use the arrow keys after I'm done writing. It just feels like it's closer. But maybe I have to change the keys for switching between modes. Yeah. Mm. Most languages only have a single string type. Rust doesn't, so it kind of confuses people. Yeah, there's the string slice, and the normal string, let's say. It's probably a little bit more annoying to do things because of that. And for some reason, I can't go to the end of the line with this. I have to switch between modes, which is a little bit strange. My background is kind of mechanical engineering, let's say. So mechanical engineering, I dropped out of college, mechanical engineering college to play poker. And then I started learning programming while streaming. And the reason why I'm learning Rust is for several different reasons, but I want to implement Rust in one of the projects that I was building, that I am building, which is Chain Data, which is a data analysis tool, let's say, for the blockchain. I want to gather a bunch of data from the blockchain, and then I want to build models and run studies about social structures and how they relate to money, and eventually connect that to AI, or try to connect that to AI. And the main thing that's what made me want to do it, like the trigger, was that I was searching for a library in Python that is faster for analyzing data. And then I looked at one of the libraries which is called Polars, and I read an article about it. And Polars is written in Rust, and I wanted to learn Rust for some time, and I had this intuition about it for some reason. So I decided that this is a good idea to learn it now, and it's also gonna help me understand more of the low level of how programming works, and it's gonna make me, I think, it's gonna make me a better programmer overall. So I think it makes sense to try to incorporate that into the project that I'm doing now and uh, achieve several things at the same time. Yeah, I think I'll continue to use the arrows to move after I reach the end of the thing. And then I'll only switch once I have to move very far or do something else. Okay. So first you print the gas number, then please input your gas, then create a variable which is a string of gas. Oh, I didn't import the main thing there. Let's use this to go there. And then, even though it's low in the beginning, I feel like, not I feel, I have to use the Vim bindings, so I get used to doing that. Otherwise, what's the point? Oh, looks like Shift J deletes a line. And I have to see. The thing is that it's kind of hard to search for this, but how people get to the end of the line when there is a semicolon and switch between, what's the best way to switch between modes, I think. Because I'm not sure if I'm doing the best way by using the arrow keys when I get there. In the middle is this one. Okay. So you create the variable, which is a string, and then use the standard library to create the inputs. The standard library is pretty similar to C++, I think. So I think it's the same way, or very not the same way, but very similar in C++ to get user input and to create output. And then there's methods, which probably, yeah, reads the string. I'm not sure actually what this does. Oh, I guess it creates the string, then borrows the string to the method. And this is gonna allow this is gonna allow for reading the line that the people put there. Yeah, for printing. This code contains a lot of information, so let's go over it line by line. Should obtain user input and then print the result as output. Also, another thing that I wanna see later, which I've kind of seen some videos about it, is people talking about WebAssembly. And I think WebAssembly seems to be a tool that you can use to write C++ or Rust and then display on the browser. And that seems really interesting to me because that's something that I've always, ever since I learned that C++, the JavaScript comes from C++ and Python I think comes from C. I was trying to think about different ways to use C++ to display things in the browser or a low-level language, but I never really, I didn't study that a lot, and I remember I did some research, but I couldn't find anything about it. And it seems to me that it would be a lot better. On the downside of that, and that's something that John Carmack was discussing with Lex, is that the bigger the software is and the bigger the company is, it becomes harder and harder to find people that know lower level languages. And then it becomes a lot better to have JavaScript or those languages like that because it's easier to find people. But from a technical standpoint, I think if you're thinking just about efficiency, for me, it seems a lot better to just try to write everything on lower level languages as much as possible because it's just faster. Basically, any language that supports WebAssembly or C++ were one of the first that did it. Okay. Yeah, but the tricky thing is using those languages to put stuff on the browser because another thing is that JavaScript and Python and all these libraries and all these languages, they have a bunch of libraries that people built to deal with stuff like synchronous programming and not only that, but graphs and things like that, creating buttons and all of this stuff, and like the whole frameworks and the paradigms. And I couldn't find. It's probably because I didn't search hard enough, but I couldn't find anything. I know that Rust has a library called Brew or something like that that goes along with React for the backend, but it's not the same thing. Like I was thinking about a way to only use either Rust or C++ to code not only the backend, but the front end as well. Like the whole thing in just one lower level language. And to me, that seems that it would be the best. But then it would be really hard to find libraries that do the stuff that you're trying to do because there isn't a lot of people doing that, I think. And the reason why is for the things I was talking about, where the bigger you go, the harder it becomes to find people. So it becomes, and not only that, it's faster to develop, I think, in higher level languages. It's the bridge needed to connect languages that are not JS to the browser. Curiously, people are trying to bring WebAssembly out of the browser as a form of executing portable code in the sandbox. Not sure what do you mean by that, man. I don't understand WebAssembly really well. I just know that it's something that people use to code in C++, and then it has something to do with the browser. But I'm not sure. I don't understand the connection really well. And compilers is another thing that I should study at some point as well to understand. Because I think compilers are the bridge between languages, and it's pretty much the thing that makes each language different, and the reason why I have different languages, I think. One of the things that maybe I would tweet about this, I think, that I really don't understand is why every single language, not every single language, but most languages have different syntax for something like a print statement. It feels very inefficient to me. Like, why would you do something like that? Why isn't every language has the same syntax for something simple? Because it feels like it just overcomplicates things for people to learn multiple different languages at the same time. If the principle is the same, then what's the point of changing the syntax? I don't understand. But it probably has something to do with the way the compiler works and the paradigm of the language. So If a type you want to use isn't in the preload, you have to bring that type into scope explicitly with a use statement. Okay, I think this stuff I can go over. Maybe I'll go really fast on the first initial parts, and then when I get to structs and nums and stuff like that, I'll stop and go slower. Things I learned with programming is that nothing is simple, not even printing to the console. Yeah, I imagine there's a bunch of code behind the scenes, right? That's part of the language in making that happen. But it's still, it's kind of weird if you think about it, because even if the code is complex, why make the syntax different? It doesn't make a lot of sense to me. But I guess I understand because in Rust it seems like the exclamation point is used to create macros, and macros are something from the language. And in JavaScript is console.log, and the reason why is because you have the browser, so it's kind of different. And then in Python is print because it's neither one of these cases. So both Rust and JavaScript they do different because there's different things in the language that goes with that. So that might be the reason, I guess. And then Solidity I think is console.log as well. But then it comes from an external library. But yeah, I think it's the same thing as JavaScript. And then Rust is the standard output, standard input, I think. Designing a language is like an art more than a science. People have different takes on how to do things. Yeah, and I guess the history also is responsible for that because the way things develop, then people don't necessarily come together and say, "Oh, let's create this language," and then at the same time, like it's not like people that created Python were talking about people that created JavaScript, and then they both decided what to do at the same time. I don't think that's how it happened. So there might be one of the reasons as well. But because if the issue is the syntax only, if there isn't anything about the syntax that is special, I feel like people should reach a consensus between them at some point. Like, let's make this simpler for everyone and just replace syntax for basic things into the same one. Like, why every single language needs to have a different syntax for a function? It doesn't make sense for me. So fn, and then you have function in JavaScript, and then you have def in Python. It feels like it's more of a ego thing of people trying to put their own take, but it severely damages the ability of people to learn things faster. Because if you imagine that every language had the same syntax for most of these things, it would be a lot easier to find people to hire, because you would only have to learn one language and then automatically you know a bunch of them. But maybe it's not that big of a deal because it's just syntax anyway. So who cares? Another program is getting interesting. There's a lot going on in this line. For an example, I think I'm gonna skip this part. It's too easy. It's gonna talk about a bunch of basic stuff. Maybe this one I read. There is a comic I like. There's 14 different standards for doing X. That's atrocious. We should make a new one to unify it. Yeah. Now we have different standards, and then the standards have different syntax, and it's just turtles all the way down. Next, we need to generate a circle number that the user will try to guess. The circle number should be different every time, so the game is more fun. First thing does provide a rand crate with set functionality. Using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we'll be building is a binary crate, which is an executable. The rand crate is a library crate. which contains code intended to be used in other programs and can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before I can write code that uses rand, we need to modify the cargo.tom file to include the rand crate as a dependency. Open that file now and add the following line to the bottom beneath the dependencies. Yeah, I guess that's one of my motivations for another one of my motivations for understanding these lower level languages. It's because the way that I think about it, oh, the way that I think the gap between someone that is good and someone that is extremely good in programming comes from understanding all of the complexity that is underneath the simple code that you're writing. So it's not necessarily that writing code in Python or JavaScript is bad. Is that most people don't understand the underlying ocean of information that exists in order to make that stuff simple. Every time you run into bugs, those people are going to take far more time solving those bugs because a bug is just when all the hidden complexity comes to the surface, and then you have to think about all of these things. And if you understand how, or if you search for or study lower level languages and then assembly and operation system and all these libraries and the way the compilers work, I think you'll become a lot faster in debugging everything because you understand more how everything is connected underneath the surface. Current file, everything that follows a header is part of that section that continues until another section starts. In dependencies, you tell Cargo which external crates your project depends on and which version of those crates you require. In this case, we specified the rand crate with the semantic version specifier. Cargo understands semantic versioning, sometimes called semver, which is a standard for writing version numbers. I think, yeah, I've seen stuff about this on FreeCodeCamp. I think I have the file here still that describes what each one of the numbers mean and the versions. Cargo considers these versions to have a public API compatible with version. Oh, another thing that I want to look at is because I remember seeing someone talking about how having internet is necessary for running Rust. So I wonder if the language itself is on the internet. Like, I'm not sure. I don't understand how that works pretty well. I think when you're using Python or other languages, you download the language and then all the files that make the language exist in your computer. But I think on Rust it might be different, where some of the files are online, but I'm not really sure if that makes sense. So maybe it's something that I'm gonna look into the future. Thanks for following. I'm not sure who it is, but yeah, thank you. Uh, Now, without changing any of the code, let's build the project as shown in listing 2.2/2. Oh, I have to run this to download the dependency, I think. You may see different version numbers, but they will be compatible with the code, thanks to Semver. Different lines depending on the operating system, and the lines may be in a different order. When include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of data from crates.io, where people in the Rust ecosystem post their open source Rust projects for others to use. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed rand as a dependency, Cargo also grabbed other crates that rand depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. If you immediately run cargo build again without making any changes, you won't get any output aside from the finish line. Cargo knows it has already downloaded and compiled the dependencies and you haven't changed anything about them in your cargo.tom file. Cargo also knows that you haven't changed anything about your code, so then compile the reader. Okay. I'm not sure how important it is to read this stuff. I want to get through the struct implement part, I think. So it's both it's struct, enums, implement. I think that I'm probably gonna have the most trouble with because there are new concepts for me. And then obviously the borrow and checking thing, which is also different. So I think those are the important parts. But these ones might be important as well because they're kind of the fundamentals of how the thing works. But I think it's similar to other languages. It's a little bit different, but similar. Cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds our code. Cargo will use only the versions of the dependencies you specify until you indicate otherwise. For example, say that the next week version 0.8.4 of the rand crate comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates the cargo.log file the first time you run cargo build, so we now have this in the guessing game directory. Okay, so the cargo.log contains the version of the dependencies when you first run it, I think. I think it would be better with Rust by example instead of the book. What's Rust by example? Is another book or something else? The interactive training site? My goal initially was to watch a bunch of videos, and then I still
Hello
think I'm
and
gonna
welcome to.
watch. So I started by watching these ones first, and then I watched a couple of other ones, and then after I watched a bunch of videos, I would copy these videos here, watch these videos and copy what he does, and after that modify the code for my purposes on my own. But I thought that this idea of reading the book was good because this guy did it, and it seems like it is more hands-on than just watching videos, but it's not so hands-on that I'm completely lost. So I thought it was a good progression. Oh, okay. Um, but do you know if this stuff is important to learn? Uh, these things here, or I can skip through? Because it seems like sometimes these things are really important. That's why it's hard to. Because usually the fundamentals of things are important, and you need to spend your time with them. But this is feeling more like something that it doesn't really matter, given that I already watched some videos and I kind of know how it works. Oh, isn't the same book that I'm reading? I think it's the same book. Oh, but here it doesn't. It just have has the examples, I think. Oh, okay. The other thing that I have to know is the most common methods as well for strings and things like that. But I think I can just look at the documentation later and then write them down and try to understand them and memorize them. Oh, it's more focused on examples. Yeah. So what I'm gonna do is go through the examples, and then if I feel like it's not enough, then I'll go back to this stuff. And to use the libraries, I only have to use to type here, I think. Let's see if this runs. Maybe we should do cargo build first. That doesn't work. Oh, unused the import, so it does work. Okay, it works. It's just warning that there's an unused import. And then to use this thing, how would I use it? So I think it's Ingenio. Okay. How do I accept this suggestion? Because with tab is not working. Yeah, cargo. I went through that part. I just thought there was a mistake here, but is actually working. It's just that I didn't realize that it's just giving me the warning, but it's still running. Honestly, it doesn't seem like it's gonna be that difficult to learn. It might take some time, but I mean, maybe to become really good at it is probably uh, why it's difficult. The part that is difficult. Yeah, I think that's gonna be the hardest part is figuring out how when to use the stuff that I'm not used to. When to use struct implements, enums, and then the borrow and checking thing. Okay, this is easy. Rust provides access to a wide variety of primitives. A sample includes signed integers. Oh, this stuff is gonna be hard as well because I'm not used to that. And also the typing thing, the types thing is something that it annoys me a lot. But everyone that knows how to code or is good, very good, seems to like that and say that is important once you have a lot of code. So it's probably important, but I hate it. Uh, from when I was trying to use TypeScript on the my project because you have to figure out the type of everything. It's just an additional thing to worry about when you not when you're doing your own types, but when you're getting types from external libraries and they don't have them, then it's kind of like what do I do now? Yeah, it's not only use a bunch of people. Yeah, so I guess it's just a practice thing. I'll probably get used to it at some point. Yeah, that's probably the reason. When coding yourself, then yeah, types get in your way, but when maintaining other people code, types are a godsend. Okay, yeah, it's because so far I haven't been part of a project or something like that or worked with other people, so I don't see the benefit because it doesn't matter to me. Like, why do I need this for debugging? I don't feel the difference, and it seems like an additional thing, but yeah, I get it. If yeah, and if most people are saying that it's good, it's probably there's probably some use to it. Oh, tuples is another thing that I have to study because I've seen that there were some questions here about tuples that they had. Yeah. I think I'm also gonna go through over this list here. Maybe not today, but sometime. because these questions seem to be really good to learn. At least I learned a lot when I was going through the Node.js. I feel like all the questions made me understand everything, and these ones probably are talking about important things that you have to know for Rust. Talking from experience, when did I write this? I don't remember what it does. Yeah. Despite the value of a unit type being a tuple, it is not considered a compound type because it does not contain multiple values. Variables can always be type annotated. Numbers may additionally be annotated via suffix or by default. Integers default to I32 and floats to F64. Note that Rust can also infer types from context. This is gonna be difficult, I think, to know when to use when, but it's not that difficult, I think. It's also always confusing for me when to the switch from binary to decimals. I'm gonna type this out just so hopefully it's better than just reading for maybe getting used to writing stuff on the language. Oh, I forgot to. No, I did typo here. I don't understand. Okay, suffix annotation. So it's just another way to say what type it is. Seems more confusing than the other one. I'm not gonna do this comments here. Oh, so this is showing the default, so I have to do. That's why there is no type there. I'm not gonna keep this, but still gonna write it. Maybe a better thing than reading the book is actually going through the list I have there and trying to figure out each thing. Because I think that's gonna force me, not force me, but uh, because I think I already know the things that I'm not sure, really sure about. So, but I'm not re quite sure if I'm ready yet to really start the project. Because it might be, once it starts, it might be really hard. I don't think I have the fundamentals down yet. I don't like this syntax here. Hmm. Yeah, I think I've seen this principle. I think I'll quickly look at the other ones, and maybe I'll write down on the things that I'm not sure about. Rust contour data types are formed mainly through the two keyword struct, define structure, and non-defined enumeration. I think these are the two ones that I have the most difficult with, because it's hard to associate them with other programming languages. Like, it's hard to see the point of using them, especially enum, I think. I've seen people use it before, but it's hard to know. And in general, I think this is the hardest part, is not how the things work, but when to use them. Because that goes into, and it still is kind of a difficult thing to try to think about. Because what approach can I use in order to be able to know when to use them, if I feel like I can do everything without them. That's the thing. But maybe I can't. Constants can also be created via the constant static keywords. Yeah. Okay. Rust provides type safety via static typing. Variable bindings can be type annotated with declared. However, in most cases, the compiler will be able to infer the type of the variable from the context, heavily reducing the annotation burden. Values like literals can be bound to variables using the lat binding. Types. You can add in the number likes. Oh, and it doesn't change the value? Yeah, that feels like it's better to read if it's a big number. Let's provide several mechanisms to change or define the type of primitive and user defined types. The following section covers casting between primitive types, specifying the desired type of literals using type interface. Uh, so yeah, casting doesn't change. Okay. I don't like the annotation with the type in the end though. But in this way that you wrote with the underscores between, it is a lot more clear. But I still prefer the other one where you define like this. I think it's just easier to see. Rust provides no implicit type conversion coercion between primitive types, but explicitly type conversion casting can be performed using the ask keyword. Rules for converting between integral types follows C conventions generally, except in cases where C has undefined behavior. The behavior of all casts between integral types is well defined in Rust. Oh, macros seems to be another thing that is hard, but it's more advanced. So maybe macros work like decorators, but I'm not sure. Or start the PC. Good luck with learning Rust by Rabbi. Oh, sure. Thank you, man. Last decimal. Okay. So this is just using the same thing that you talked about. Okay, so far doesn't seem like anything. Oh, so the new thing here is that you can use as and then define which type is gonna be. Oh, the other thing that is difficult, that might be difficult probably, is traits, which I haven't seen on any other languages, other language besides Rust. And it seems like something. Yeah, that's the thing that I was having issue about is how how can you have inheritance? It's not really a part of the paradigm of the language, I think, because Rust is composition, but if you have kind of want to have the same effect, so traits seems like they work like abstract classes, but I didn't figure out how it works. Uh, that's the question: how to make? Can you use a bunch of implementations for one struct or just one? Because in the way that I was thinking about struct plus implement is equal to a class in Rust. It's kind of like the same thing, but not really. But then it becomes if what if you wanna have the same struct for several different implementations? Yeah, but that doesn't make sense. I think about it because you can just put everything on the main implementation. But there was something about that was not really clear. Numeric literals can be type annotated by adding the type as a suffix. As an example, which is specified that the literal 42 should have the type int32, right? 42 i32. The type of unsuffixed numeric literals will depend on how they are used. If no constraints exist, the compiler will use i32 for integers and f64 for floating numbers. I think I went over that already. There are some concepts used in the previous code that haven't been explained yet. Here's a brief explanation for the impatient readers. Standard mem size of val is a function but called with its full path. Okay, here comes from the standard library. Code can be split in logical units called modules. In this case, the size of val function is defined in the mem module. Okay, yeah, so it makes sense. So it's the same thing from other languages, but instead of the dots, it uses two dots. It uses this instead of the dot to access the files, I guess. Because standard it works kind of like a class or a package, then it goes into the thing inference. But it's still, I think that's the tricky part for me. That's probably what I'm going to spend most of the time trying to understand. Is the difference in this paradigm of using structs and implementations and how packages work to access the classes. The type inference engine is pretty smart. It does more than looking at the types of the value expression during an initialization. It also looks at how the variable is used afterwards to infer its type. Here's an advanced example of type inference. Type inference. Because of the notation, the compiler knows that element has type U8. Create an empty vector or global array. At this point, the compiler doesn't know the exact type of vac, it just knows that it's a vector of something vac. Insert element in the vector. Now the compiler knows that the vac is a vector of U8s. Okay, I get it. So I guess you can't have vectors with mixed variables, mixed types, probably. Like you can on higher level languages. No type of notation of variables, which is another thing that might be difficult for me to deal with. I guess most of the situations I probably use an object, but I also think I use arrays very frequently that have mixed types of things in them. So it's probably gonna be something challenging as well, I guess. Oh, one idea that I had, which might be good, is I can go through Python code that I have here and then try to translate that into Rust. That's actually a very good idea, I think, because I can take the all the code that I have for Flash loan bots that I have, that from other people that I studied in the past, and then I can translate that into Rust. That might be, yeah. I think I'm gonna do that. And there's a bunch of them. Oh, here. And this is just, yeah, but I think that's probably a good idea. So there's something else that I was gonna do as well after reading this book that I forgot. Oh, go over the topics I have here. So I think I'll go over the topics first. I'll read the book, then go over the topics. Then I'm gonna do that. I'm gonna get open these files and then translate this code for these flashbots. Maybe I'll choose other code, but I'll translate that code into Rust. And then because then I'm gonna have an idea. Maybe I should, yeah, I should probably instead of using this, I should use something that I've written myself because that way I'm gonna understand because the code that I've written is already my natural inclination to do things. So when I translate into Rust, it's gonna click on my mind what the pain points are gonna be for me to learn. And I think that's very good. Maybe I should do that before I even go to the topics because then as I study this, I'm gonna be aware of the things that are difficult for me. But the thing is, I don't have a lot of stuff that I. Yeah, the problem is that most of the Python code I have is depends on a bunch of libraries, so it might not be that possible to do that. But maybe I'll translate just the parts that don't have libraries, like dealing with arrays and things like that. I can do both. I'm gonna translate one of my projects, just the without the libraries. I'm gonna ignore the libraries and just see the operations with arrays and things like that. And then the other project that I'm gonna do is gonna be one of the flashbots ones after I do this. And then after that I study this stuff. Aliasing. The type statements can be used to give a new name to an existing type. Types must have upper camel case names, or the compiler will raise a warning. The exception to this rule are the primitive types. Okay, so all types need to be camel case. I wonder, I think there is interface as well, but I'm not sure. What's the difference? Yeah, when should I think, oh, enums is when you have arbitrary types, I think. And then a type is just when you define the specific type for the variable. I guess that's the difference. next one. Primitive types can be converted to each other through casting. Rust addresses conversion between custom types, struct and enum, by the use of traits. Okay, conversion between custom types by the use of traits. The generic conversions will use the from and into traits. However, there are more specific ones for the more common cases, in particular when converting to and from string as. A trait is a collection of methods defined for an unknown type, self. They can access other methods declared in the same trait. Traits can be implemented for any data type. In the example below, we define animal, a group of methods. The animal trait is then implemented for the sheep data type, allowing the use of methods from animal with a sheep. Traits can provide default method definitions. I understand, kind of. Okay, so this is not an implementation, it's just the trait. And then it's implementing the struct. So I guess the answer to that question is each struct can only have one implementation. I guess that's how it works. But yeah, what if I wanna implement one struct for multiple? Yeah, but why would I want to do that? That's the thing. I think the problem is I'm thinking about classes and it's not really the same. Because I'm thinking from the classes paradigm of inheritance. And I don't understand really well the difference between the object-oriented stuff and the composition. I watched a couple of videos and I kind of get it, but it's a little bit hard for to actually understand the fundamental differences. You can implement multiple traits for a given struct. Oh, okay. But do they all have to have the same name? Oh, implement animal for ship. But animal is a trait. Yeah, so traits do seem like they work in the same way as abstract classes. It's like a template that you create and you can use for any other implementation you want. And I guess then you call the methods on the sheep. Yeah, self is the implementer type sheep. So you just add different methods based on the template for the sheep implementation. I think I kind of get it now, the trait part, but the struct is a little bit difficult. Abstract classes interface and traits are sort of the same thing. Okay. But I'm gonna research this later as well, more about, because I think this is important. Addresses conversion between custom types, struct and enums by the use of traits. The generic conversion will use the from and into traits. However, there are more specific ones for the more common cases. So I guess what they're talking about is using a trait to create to change the implementation from struct. This is not really clear to me. So you have a struct and you need to convert to an enum, and then you use the trait to do it. That's what it seems like. Let's look at these ones. Use to value to the value to value conversions while consuming the input value. Zero into for implementing from over into because implementing from automatically provides implementations. The from trait simplifies error handling by allowing a function to return a single error type that encapsulates multiple error types. I think maybe I get it, but not really. The from trait is intended for perfect conversions. If the conversion can fail or is not perfect, use try from. Implies into u for t. From is a reflexive, which means that from for t is implemented. Oh, so I think this is a thing as well. Whenever you initialize a string like this, is actually a string slice. So this is why you have to. This is how you convert probably to a string that. In the string slice, the only difference is the memory, because string slices have a fixed memory, and then normal, let's say, strings have the growable memory. The docs also have other styles if flight mode hurts you, like most people will search. Okay, nice. Yeah, I don't like the light mode. This one's better. I kind of like this one. So I get that it's a conversion of types, but I don't understand really well. So it's converting this from for any, or I guess from this type to this type, but How does the trait does that? I guess the rest is just the implementations. Oh, it's just a function. Maybe, yeah, probably if I look at the source. Oh, interesting. So this is the source code, I think, for all the functions. And I think these are macros. Now, how do I go through this one? Yeah, 106 doesn't help that much. From T for U means you can convert the T into a U. How the conversion is done is defined in the body of the method. Yeah, that's what I was thinking about. Oh, when you say the body of the method, are you talking about the body of the trait method? Because the trait is the just I think the only purpose is to declare which functions are going to be implemented, but then you have to use the implement should actually implement those functions. So, or is it always from the trait that the conversion happens? Okay, so I guess I get it now. So it's not the trait that is doing the implementation. The trait has the declared function that is gonna do the conversion, and that conversion is doing by the implement of the trait, I think, which is a function that converts the types, which probably uses a match or something like that to verify each case. But then how does it do that? I guess when you do the for keyword, you specify what's gonna be the conversion. That makes sense. And as far as I remember, this T here is for any type. I think it's like a wild card, but I'm not really sure. Yeah, I gotta hammer down on these principles. I think that's the most important thing. So implement struct enums type, and then from there, I think it's gonna be easier. Rust program is mostly made up of a series of statements. There are a few kinds of statements in Rust. The most common two are declaring a variable binding and using a semicolon with an expression. Yeah, this is not that interesting. Flow control is probably gonna talk about the match thing. If else for whatever. Functions are declared using the fn keyword. Its arguments are type annotated just like variables. Returns a value. The return type must be specified after an arrow. A final expression in the function will be used as a return value. The return statement can be used to return a value earlier down. Okay, so it does have the return statement. And next. Rust provides a powerful module system that can be used to hierarchically split code in logical units, modules, and manage visibility, public, private between them. That's also another thing that the other languages don't have, the languages that I know. But I don't think this is in particular is gonna be that hard to understand. It's gonna come with practice, but it's not really that hard, I think. Maybe I'm wrong about this as well. Module is a collection of items, functions, structs, traits, templates. Okay. A crate is a compilation unit in Rust. Whenever Rust sees some file is called, it's treated as a crate file. As mod declarations in it, then the contents of the module files would be inserted in places where mod declarations in the crate file are found before running the compiler over it. In other words, modules do not get compiled individually, only crates get compiled. Not get compiled individually, only crates get compiled. Which is the whole thing, I think. A crate can be compiled into a binary or into a library. By default, Rust will produce a binary from a crate. This behavior can be overridden by passing the crate type flag to lib. Attributes. An attribute is a metadata applied to some module, crate, or item. This metadata can be used for additional compilation of code. Set crate name, version, and type binary. Disable links, enable compiler features. When attributes apply to a whole crate, their syntax is this. I'm not sure what exactly this means. I understand what it's saying, but the implications, let's say, of this. And when they apply to a module or item, the syntax is this. So I think it's the same principle from Python, where if you put the if name equals main in the file, it's considered as a script, which means that it's not gonna run when you import it. I think. So this is kind of like the same thing, but I'm not pretty sure. Attributes can take arguments with different syntaxes. Attributes can have multiple values and be separated multiple lines. For example, an attribute is allowed.code, so any warning that would be emitted for things like unused functions will not emit. Okay. Yeah, I think I get it. I think it's the same. It was what kind of like I was talking about, but slightly different for the if name equals main. Configuration conditional checks are possible through two different operators. Attribute position, macro, expressions. While the former enables conditional compilation, the latter conditionally evaluates to true or false. The rules allowing for checks at runtime. Both utilize identical argument syntax. Does not remove any code and only evaluates to true or false. For example, all blocks in an if-else expression need to be valid when SVG exclamation is used for the condition, regardless of what SVG is evaluating. This function only gets compiled if the target OS is Linux. And this function only gets compiled if the target OS is not Linux. Pretty much the same thing here, but Generics is the topic of generalizing types and functionalities through broader cases. This is extremely useful for reducing code duplication in many ways, but can call for rather involved syntax. Namely, being generic requires taking great care to specify over which types a generic type is actually considered valid. Simplest and most common use of generics is for type parameters. Type parameter is specified as generic by the use of angle brackets and upper camel case. Okay, so generic type parameters are typically represented as t. In Rust, generic also describes anything that accepts one or more generic types, one or more generic type parameters. Any type specified as a generic type parameter is generic, and everything else is concrete, non-generic. For example, define a generic function named foo that takes an argument t of any type. Because t has been specified as generic type parameter using t, it is considered generic when used here as args t. This is the case even if t has previously been defined as a struct. And read this again. Oh, okay. So if t was a struct before, then because it wrote like this, it becomes a generic type. I guess that's what it means. This example shows some of the syntax in action. T provides the first use of t, no single gen, the generic type. Because the type parameter t is generic, it could be anything, including the concrete type A defined at the top. Yeah, I think I get it. Right back. Let me see how much time I have. I think I'm gonna read the book before. I'm gonna look at all these topics before I stop. I'm probably gonna go through all these topics and then stop. That's probably better. Then next time we'll do the other stuff I was talking about. Right back. Maybe when it gets time to try to translate my code from other languages into Rust, I should actually try to actually replicate everything and see if there are equivalent libraries uh, for Python and in Rust. I think that would be really good because they're not only can I replicate because that I will be also able to redo everything in Rust and it's gonna be faster, I think. But if that's too hard, because I'm pretty sure there's not gonna be, I think Rust, maybe there will actually. When was Rust created actually? Because I think it's a lot newer than uh, than Python. So there's probably less packages. Well, 12 years ago ish first appeared. So maybe there are equivalent libraries, but I'm not sure. Python, I know is way before. I don't know exactly when, but yeah, late. Okay, 89. So if there are uh, equivalent libraries, yeah, but then the methods are gonna be all different. But I think it's still a good way to learn, probably. Scoping rules. Scopes play an important part in ownership, borrowing, and lifetimes. That is, they indicate to the compiler when borrows are valid. Oh, in the last case, if uh, as I do that, if it's hard to do, then I can just watch the videos as well. There's no. Yeah, and I think doing that's probably better than jumping into the project right away or trying to follow the other guy and copy this stuff. I think is gonna be better. I'm still probably gonna do that anyway after to go over the tutorial from the other guy and try to make the code, uh, write it along the code as he goes, and then translate that code into the thing that I actually want to do. But before that, it's probably better to translate the code. Scope plays an important role in ownership. That is, they indicate to the compiler when borrows are valid, when resources can't be freed, variables are created or destroyed. Traits, macros. A trait is a collection of methods defined for an unknown type self. They can access other methods declared in the same trait. Traits can be implemented for any data type. In the example below, we define animal, a group of methods. The animal trait is then implemented for the sheep data type. Okay, I already read this. It's the other one. Macro rules. Rust provides a powerful macro system that allows meta programming. As you've seen in previous chapters, macro look like functions, except that their name ends with a bang exclamation. But instead of generating a function call, macros are expanded into source code that gets compiled with the rest of the program. So it's pretty much the same principle as a decorator, I think. But maybe it's different in the way that implements the other code. Because a decorator is just a function that puts the function inside of the other function. But I think it's pretty much the same thing. I don't see that much of a difference. However, unlike macros in C and other languages, Rust macros are expanded into abstract syntax trees rather than string preprocessing. This is interesting. So don't get unexpected precedence bugs. Macros are created using the macro rules macro. This is a simple macro named say hello. Indicates that the macro takes no arguments. The macro will expand into the contents of this block. So it is pretty much the same as the decorator, I think. But this, I'm trying to think about different ways to write this because I think it's really interesting. It's gonna help me understand the other languages as well. I'm not sure what this means here exactly. because they don't talk about uh I guess they're talking about C, so I don't know enough of C to know if they have macros or not. It says C in other languages, but they doesn't say that if it is macros as well or if it's something else. But I think I'm just gonna copy this full line here and then I'll search later. But I think it's gonna be difficult to find something because that is not exactly what I want to know. I don't understand what this string preprocessing means. And I kind of think I get it, but not really. I have a rough idea of what this might mean, but not really sure. Why are macros useful? Don't repeat yourself. There are many cases where you may need similar functionality in multiple places, but with different types. Often, writing a macro is a useful way to avoid repeating code. Domain-specific language. Macros allow you to define special syntax for a specific purpose. Oh, I think I've seen some of this before, where the guy was using regular expressions in the beginning of a macro to then he was talking about some I think was the advanced ones that I was watching. This guy here. Yeah, it was exactly this video, I think. But it didn't obviously it didn't understand what he was doing. Variadic interfaces. Sometimes you want to define an interface that takes a variable number of arguments. An example is ln, which could print line, which could take any number of arguments depending on the formatted string. Okay. Handling. Handling is the process of handling the possibility of failure. For example, failing to read a file and then continuing to use that bad input would clearly be problematic. Noticing and explicitly managing those errors saves the rest of the program from various pitfalls. There are various ways to deal with errors in Rust, which are described in the following subchapters. They all have more or less subtle differences and different use cases. As a rule of thumb, an explicit panic is mainly useful for tests and dealing with unrecoverable errors. For prototyping, it can be useful, for example, when dealing with functions that haven't been implemented yet. But in those cases, the more descriptive unimplemented is better. In tests, panic is a reasonable way to explicitly fail. Okay. So I guess this is the keyword. I'm gonna write this down. I will search later. The option types for when a value is optional or when the lack of a value is not an error condition. For example, the parent of a directory and C don't have one. When dealing with option as unwrap is fine for prototyping in cases where it's absolutely certain that there is guaranteed to be a value. However, expect is more useful since it lets you specify an error message in case something goes wrong anyway. When there is a chance that things do go wrong and the caller has to deal with the problem, use results. You can unwrap and expect them as well. Please don't do that unless it's a test or quick prototype. I'm just gonna write these things down here. And I'm probably gonna search for them later. Continuous discussion. Standard library types. The standard library provides many custom types which expand drastically on the primitives. Some of these include growable, string as like hello world, row vector, optional types, error handling, heap allocation, allocated pointers. I think I already wrote some of these. Probably just gonna write it again. But I'm pretty sure I wrote down something to do with heap there. Already went over this. I'll go over this later, probably another time. I think it's better to watch videos first and then only after I do all of this stuff. I think I'm gonna watch videos in between as well. As I convert my code into Rust and as I go through these topics, I'm probably gonna watch a bunch of videos as well. Standard library types. The standard library provides many custom types which expand drastically on the primitives. Some of these include, okay, already read this. Many other types are provided by the standard library, which support things such as threads, channels, file, I/O. These expand beyond what the primitives provide. Yeah. Some topics aren't exactly relevant to how you program, but provide you tooling or infrastructure support, which just makes things better for everyone. These topics include documentation, library documentation for users via the included Rust knock. Oh, I think I remember seeing something about this way before when I was watching the course from Zero to Mastery. Integrate the Rust playpen, also known as the Rust playground, in your documentation. Rust is a programming language that cares a lot about correctness, and includes support for writing software tasks within the language itself. Testing comes in three styles: unit testing, doc testing, iteration testing. That's something I've seen other people talk about that you should do. People that it was a video that I was watching today actually. The guy was talking what should you do to become better, and this was one of the things, but I usually don't do these types of tasks, so maybe I should do them more often as well. I don't even the only time that I actually did something like this, or I did a lot of tasks, was for blockchain, for writing smart contracts. And the reason why is because the contracts, once you deploy, is just. I actually the second time that I did it, redeployed a bunch of different contracts, but it obviously wasn't. It's not the best. But it is just one of those things. Like it's the same thing. It's very similar to the TypeScript thing, where it doesn't feel really necessary, but it's probably the only because I'm working by myself and I'm not a part of a team or something. Also, Rust has support for specifying additional dependencies for tasks. The work chapter on testing, API guidelines on doc testing. And there's a lot of stuff. Tests are Rust functions that verify that the known task code is functioning in the expected manner. The bodies of the test functions typically perform some setup, run the code, and run the code bunch of tests, then assert whether the results are what we expect. More unit tests go into a test mode with these attributes. Test functions are marked with test attribute. Test fails when something in the test function panics. There's some helper macros. Think I get it. So there's the special keyword, I think. Or this is just a module. A special word for modules, yeah. I'm already tired of reading, to be honest. I think I'm gonna go over them really fast and then stop here. So you just use the macro or the other module, and then use the assert methods to say. I think I went over this already. And this is the documentation. I'm not gonna read this now. As an introduction to this section, to borrow from the official docs, one should try to minimize the amount of unsafe code in a code base. With that in mind, let's get started on safe annotations in Rust. I wish to bypass protections put in place by the compiler. Specifically, there are four primary things that unsafe is used for: dereferencing raw pointers, calling functions for methods which are unsafe, including calling a function over FFI, see a previous chapter of the book, accessing or modifying static mutable variables, implementing unsafe traits. Raw pointers and references function similarly, but references are always safe because they are guaranteed to point to valid data due to the borrow checker. The borrow checker, okay. Dereferencing a raw pointer can only be done through an unsafe block. Uh, anyway, interesting. I think I got it. Calling unsafe functions, some functions can be declared as unsafe, meaning it is the programmer's responsibility to ensure correctness instead of the compiler's. One example of this is standard slice from raw parts, which will create a slice given a pointer to the first element and the length. For a slice, one of the assumptions which must be upheld is that the pointer passing points to valid memory and that the memory pointed to is of the correct type. If these invariants are invariants aren't upheld, then the program's behavior is undefined. There's no knowing what will happen. Yeah, I'll have to spend more time on this one to think about what it means. Actually, I think like the many other things, I think I kind of get it, but uh, not really. I have to. It's gonna take space repetition to and more understanding to really know uh, these things here. Compatibility, the Rust language is fastly evolving, and because of this, certain compatibility issues can arise, despite efforts to ensure forward compatibility whenever possible. And I didn't know that Rust was actually 12 years old. If I thought it was a lot younger than that. That's a lot of time, actually. But I guess maybe it's not so much for a programming language, actually, if you compare it to the other ones. Eh, The Rust playpen is a way to experiment with Rust code through a web interface. This project is now commonly referred to as Rust Playground, using it with MD book. This allows the reader to both run your code sample but also modify and tweak it. The key here is that the adding the word editable to your code reference block separated by a comma. Okay. Additionally, you can add ignore if you want MD book to skip your code when it builds and tests. Hmm. Using it with docs, you may have noticed in some of the official Rust docs a button that says run, which opens the code sample up in a new tabs in Rust Playground. This feature is enabled if you use the doc attributes called this. Okay, so I think I'm gonna stop here. Next time I'm gonna do this stuff that I was talking about. Convert one of my projects into Rust, and then one of the projects of the Flashbots, not Flashbots, but blockchain blocks bots. So one of these bots here, and then after that I'm gonna study this stuff here, these topics, and then after that, or in between, I'm gonna watch all these videos as well, and then only after that I'll go back to the tutorial here, and yeah, actually start working on the project that I'm working on, which is the chain data thing. So see you next time.